In the previous video, we have discussed how to calculate the relative molecular mass of different compounds. Let's take one more example. Calculate the relative molecular mass of copper sulfate crystals. Its formula is CuSO4.5H2O. And the relative atomic mass of different atom is given here. Of copper it is 63.5, sulfur 32, oxygen 16 and hydrogen 1. These are the atomic masses of different elements which are present in this compound. Now we have to calculate the relative molecular mass of the given compound. So as I have told you in the previous video that in order to calculate the relative molecular mass of any particular compound, we have to add the relative atomic mass of different atoms which are present in the molecule of that compound. So here again we will do the same thing. Relative molecular mass of CuSO4.5H2O will be equal to, now here one atom of copper is there and its atomic mass is equal to 63.5. So we will write 63.5 plus one atom of sulfur is here and its atomic mass is equal to 32. So plus 32 plus here 4 atoms of oxygen are there, but the atomic mass, that is the mass of one atom of oxygen, is 16. So we will multiply by 4 in the atomic mass of oxygen in order to calculate the total atomic mass of 4 atoms of oxygen. Plus, in place of this dot sign, we will use here plus. Now here you can see 5 molecules of water are present. So in order to calculate the total mass of 5 molecules of water, we will multiply by 5 in the relative molecular mass of 1 molecule of water. So in 1 molecule of water, 2 atoms of hydrogen are there and 1 atom of oxygen is there. So the atomic mass of hydrogen atom is 1. Since here 2 atoms of hydrogen are present, so we will write 2 into 1 plus atomic mass of oxygen is 16. So plus 16. Now this is the relative molecular mass of 1 molecule of water. But here 5 molecules of water are present. So we will multiply by 5 in order to calculate the total mass. Now we will solve it. 63.5 plus 32, 4 into 16, 16, 4, 64 plus 5, 2 into 1, 2, 2 plus 16, 18. 63.5 plus 32 plus 64, 5 8 ja 40, 5 1 ja 5 and 4, 9. Now we will add it and we will get 63.5. So finally, the relative molecular mass of copper sulfate crystal is 249.5 AMU. So our next topic is percentage composition. Percentage composition of a compound is the percentage by weight of each element present in it. Means in order to calculate the percentage composition of any compound, we need to calculate the percentage by weight of different elements which are present in that compound. So in order to calculate the percentage of an element in a compound, किसी भी compound में जो elements present है, अगर उनकी हमें percentage निकालनी है on the basis of their weight, then the formula is total weight of the element in one molecule. In one molecule of that compound, the total weight of the element upon gram molecular weight of the compound. Molecular weight means relative molecular mass only. So we will divide it by the gram molecular weight of the whole compound into 100. This is the formula to calculate the percentage of any element in a compound. Total weight of the element in that compound divided by gram molecular weight of the compound into 100. Now let's discuss some questions. So let's take one question. Calculate the percentage of hydrogen in water. In the water, we have to calculate the percentage of hydrogen. And the relative atomic masses in ANU of hydrogen is 1 and oxygen is 16. So first of all, we will calculate the relative molecular mass of water, that is the gram molecular weight. And it will be atomic mass of hydrogen atom is 1, but here 2 atoms of hydrogen are there, so total will be 1 into 2 plus 1 atom of oxygen is here and its relative atomic mass is 16, so plus 16. So we got 18 as the relative molecular mass of water. Now you can see we have to calculate since the percentage of hydrogen. So since 18 gram of water contains 2 gram of hydrogen, how this 2s came? Here 2 atoms of hydrogen were there and the atomic mass of hydrogen atom means the mass of 1 atom of hydrogen is 1. So the mass of 2 atoms of hydrogen will be 2. So we can say that in 18 gram of water, 2 gram of hydrogen is there. But in order to calculate the percentage of hydrogen, we will find out in 100 gram of water how much hydrogen is present. So in 100 gram of water, or we can say 100 gram of water contains 2 upon 18 into 100. The formula which I have told you, you can apply either directly or you can do it in this way also. Total weight of hydrogen upon gram molecular weight of hydrogen into 100. So 100 gram of water contains 2 upon 18 into 100, that is 11.11 gram of hydrogen. So finally we can say that hydrogen in water is 11.11% by weight. So let's take one more question. Find the percentage mass of water in washing soda crystals. Its formula is Na2CO3 dot 10H2O. Now in this compound we have to calculate the percentage mass of water. Atomic mass of sodium is 23, carbon 12, oxygen 16 and hydrogen 1. It is already given in the question. Now first of all we will calculate the relative molecular mass of washing soda crystal. It will be 2 atoms of sodium are there and the mass of 1 atom of sodium is 23. So total mass will be 23 into 2 plus single atom of carbon is here and its mass is 12 plus 3 atoms of oxygen are there. So 16 into 3 plus So the relative molecular mass of washing soda is 286 AMU. Now we have to calculate the percentage mass of water. So we will write, since 286 gram of washing soda contains, water was here 180 gram, contains 180 gram of water. Now we will calculate the weight of water in 100 gram of washing soda, and therefore 100 gram of washing soda contains 180 upon 286 into 100, and then we will get 62.9 gram of water. So finally we can say that percentage of water in Na2CO3.10H2O is equal to 62.9%. So our next topic is empirical formula of a compound. Empirical formula of a compound is the simplest formula which gives the simplest ratio in whole numbers of atoms of different elements present in one molecule of the compound. किसी भी compound के molecule में जो different elements present होते हैं उनके number of atoms का simplest ratio जो होता है, that will be then the simplest formula which gives the simplest ratio of these number of atoms is the empirical formula of the compound. Example, you take the empirical formula of hydrogen peroxide is HO. Actual formula जो है hydrogen peroxide का वो H2O2 होता है. Now here you can see the ratio between the number of hydrogen atom and oxygen atom is 2:2 because 2 atoms of hydrogen are here and 2 atoms of oxygen are here. But the simplest ratio can be written as 1:1. 2 is the common factor here, and as a result the formula will become HO, which contains 1 atom of hydrogen and 1 atom of oxygen. So the empirical formula of hydrogen peroxide H2O2 is HO. So finally we can say that empirical formula is the simplest formula which gives the simplest ratio in whole numbers in between the number of atoms of different elements present in one molecule of the compound. In the same way, formula of glucose is C6H12O6. It contains 6 atoms of carbon, 12 atoms of hydrogen and 6 atoms of oxygen. So now here the ratio is 6:12:6 in between carbon, hydrogen and oxygen atoms, but common factor is here 6 in between in among 3 numbers 6, 12 and 6, and therefore the simplest ratio will become 1:2:1, and by using this ratio in between the number of atoms of different elements, the formula will become CH2O. This is the empirical formula of glucose, CH2O, which contains 1 atom of carbon, 2 atoms of hydrogen and 1 atom of oxygen. It is the simplest formula. Now empirical formula mass क्या होता है? Empirical formula mass means the sum of the relative atomic mass of different elements which are present in the empirical formula of the compound. Let's take here, since the empirical formula of hydrogen peroxide, in hydrogen peroxide, empirical formula of H2O2 is HO. Now in order to calculate the empirical formula mass, we will add the relative atomic masses of different atoms which are present in the empirical formula of the compound. And as a result, we can write down empirical formula mass of HO will be equal to, it contains one atom of hydrogen, its atomic mass is 1 atom of oxygen, its atomic mass is 16. So finally we can write 17 AMU is the empirical formula mass of HO. That is the empirical formula of hydrogen peroxide. So now many questions are given in the exercise. You can complete them based on percentage, composition, molecular mass, empirical formula. Lot of questions are given. You can complete them. Thank you.